All right, all right, all right, all right, all right. All right, let's look at current events. Let me see. Let me see. Okay. So, what is all this? AI founders will learn the bitter lesson. Um, Interesting. So what are we seeing here? Historically, um, okay. Where's Harvey here? Harvey. Professional class AI. All right. So where were we? Oh, shoot. Okay. So I'm gonna put this somewhere. All right. So we were doing C++, sure. Are these by percentage completion? Probably, right? Maybe. Oh no, it's by last touched. So wait, did I touch JavaScript? Let's just go here. Okay, so did we finish interest is interesting? Yeah, right? It's all done. Okay. So, fine, easy. Okay, let's jump into whatever this next one is. Ellen's Alien Game. All right, cool, cool. Let's see what it's all about. Oh, it's about quite a bit, I guess. Okay, oop. Oh, interesting. Okay, sure. Let's do a little oop. Why not? Why not? Let's do a little oop. OOP is centered around classes, user-defined types of data with their own set of related functions. We will start with the basics and we'll cover more advanced topics further down the syllabus tree. Okay, classes can have member variables and member functions. They are accessed by the member selection operator dot. Just as variables outside of classes, it is advisable to initialize member variables with a value upon declaration. This value will then become the default for newly created objects of this class. All right. Classes offer the option to restrict access to their members. The two basic access specifiers are private and public. Private members are not accessible from outside the class. Public members can be accessed freely. All members of a class are private by default. Only members explicitly marked with public are freely usable outside of the class. Basic example. The definition of a class can be seen in the following example. Notice the semicolon after the definition. Okay, so we're going to start a class, and the first thing they told us was to notice the semicolon. So we're going to go to where this matches down here. Okay, sure. All right, so now this next comment says, from here on, all members are publicly accessible. Defines the public member function cast spell. Okay, so we said, oh, let's make a public area, right? Now we're going to make a function int cast spell return damage. All right, so since we defined the function inside of this class, it is a class member function, right? Member function. Okay, so then define the public member variable name. Okay, so we have a standard string, which is called a name. Now, we have private. From here on, all members are private. Defines the private member variable damage. Okay, now we know. You can access all member variables from within the class. Take a look at damage inside the cast spell function. You cannot read or change private members outside of the class. Okay, so we have a wizard, Silverhand. All right, so now we have an instance, right? Calling the cast excuse me, the cast spell function is okay. It is public. Cast spell. Okay, so what came back? A 5. That's fine. Name is public and can be changed. Okay, so we changed it from nothing to Laron. I don't like this name. Damage is private. Silverhand damage equals 500. Compilation error. Oh no, so the compiler will say don't. It'll say stop it. Stop it. And then I guess we will. All right, I guess we'll stop it and we'll just change it. Okay, so constructors. Constructors offer the possibility to assign values to member variables at object creation. They have the same name as the class and do not have a return type. Oh, nice. A class can have several constructors. This is useful if you do not always have a need to set all variables. Sometimes you might want to keep everything at default but change the name variable. In the case of a significant wizard, you might want to change the damage as well. So you need 2 constructors. Okay, let's take a look at our example. So we placed 2 public constructors before the cast spell. And this one takes a new name, fun, and we just assign it, easy, cool. And this one takes a new name and also a new damage, and we just assign it, easy peasy. So now we can see that we can sort of instantiate L with the name 11. All right, 5 damage because we didn't change the private damage, and a Vecna, but this one has 50. Ah, that's crazy. All right, so constructors are a big topic and have many nuances. If you are not explicitly defining a constructor for your class, then and only then, and only I can't speak. Then and only then the compiler will do the job for you. So if we go to the first example above, then we didn't show a constructor at all. But here we used a default constructor that we didn't even write but was provided. Right? Fair enough. All variables are set to the value that was stated in the definition of the class, okay? If you had not given any values in that definition, the variables might be uninitialized, which might have unintended consequences. All right? Okay, so then structs. Structs came from the language's original C roots and are as old as C++ itself. They are effectively the same thing as classes with one important exception. By default, everything in a class is private. Structs, on the other hand, are public until defined otherwise. Conventionally, the struct keyword is often used for data-only structures. The class keyword is preferred for objects that need to ensure certain properties. Such an invariant could be that the damage of your wizard class cannot turn negative. The damage variable is private, and any function that changes the damage would ensure the invariant is preserved. Okay, so a simple example. So now we're making sense of OOP. So now we're going to do an assignment. Ellen is making a game where the player has to fight aliens. She has just learned about object-oriented programming, OOP, and is eager to take advantage of what using classes could offer her program. To Ellen's delight, you have offered to help, and she has given you the task of programming the aliens that the player has to fight. All right, so we'll create an alien class. So the alien class will have a constructor that accepts an x and a y int, and put them into its x-coordinate and y-coordinate member variables. Every alien will also start off with a health level of 3, so the health member variable should be initialized as well. Sure, health should be a private member variable. To let other parts of the program read the health information, Ellen wants to have a public getHealth method which returns an int. All right, so for example, we can call the alien constructor with 2, 0, and now we should be able to read its x and y coordinates and get its health. Okay. Sounds like OOP to me, baby. Now, each alien should be able to internally track its own position and health. Cool. The hit function. Ellen would like the alien class to have a hit method that decrements the health of an alien object by 1 when called. Okay, so that's what we'll do here. So after hitting it, then we can get the health again and see that it's only 2, not 3. All right. Yeah, so make sure that the health points do not drop below 0. The function should return true. Ellen wants to introduce shields at a later point, which would then report false if the shield is up. Okay, sure. IsAlive function. You realize that if the health keeps decreasing, at some point it will probably hit 0. It would be a good idea to add an isAlive method that Ellen can quickly call to check if the alien is, well, alive. Some alien instance isAlive should return a boolean. Alien get health, we got 1, isAlive true. Okay, hit get health 0, isAlive false. Okay, then there's a teleport function. In Ellen's game, the aliens can teleport. You will need to write a teleport method that takes x new and y new values and changes the alien's coordinates accordingly. For the time being, the function should return true. Ellen wants to add teleport blocking bombs in later levels, which would then report false for failed teleporting attempts. Okay, so it'll teleport 5 minus 4, and so, yeah, so we'll update those. And then there's a collision detection. If the aliens can be hit by something, then they need to be able to detect when such a collision might occur. Ellen needs to know if 2 aliens occupy the same coordinates. The collision detection function takes another alien object as an argument and returns a bool. Alright, so then if one alien is at 3, 6 and the other is at minus 2, 12, we'll say, oh, nope, not the same spot. But then if it teleports to the same spot as the first one, then we'll say true. Okay, so let's go ahead and knock this out. Do we have a stub file? Let's see what's in here. Ellen's Alien Game CPP. Okay, so there's not a ton here, obviously, yet, but that's okay. So we'll say class alien, right? And then we'll say the alien constructor, right? Is this in the public area? And it takes int x, int y, right? And then we're going to say x coordinate equals x, right? And then this one will be y coordinate, y. And then we'll say health equals 3, which is, I think that's what they told us to do. I think it's fine. So then we'll make a private area for the health. And that's int health. Should I put the 3 there as well? I don't know if it matters. And then here we will have int x coordinate, int y coordinate. And so that's okay. So then we'll add these other functions. So there was a public hit function, right? And that one returned a bool. So we'll say bool hit. And it didn't take anything. And so now we say, we said it would just return true, basically. Let's put the comment. Note, in future, if the alien is shielded, this will return false. Okay, so then here we'll say if, and we'll say health greater than 0, health minus minus. Okay, and then the next one was teleport. Did the teleport return anything? I think it might have been void. Teleport int new x, int new y, and then we'll just kind of do what we did before, basically. Okay, so this one will be new x, new y, and so that's cool. Then we had an is alive, so bool is alive, return health greater than 0. Okay, so, oh, and then there was a collision, so we'll have a bool collision detection, I think they called it. Detection, there we go. And this one takes an alien other, and then return this. So return other x coordinate equals x coordinate, and other y coordinate equals y coordinate. How's that look? That's a long line. Let me make it shorter, because I can see that my head is covering it. So let's put and like this. Is that any better? Okay. All right, so now if I try to CMake, what's it going to tell me? It's going to tell me that I have a bajillion problems, right? A bajillion. Okay, so, oh my gosh. Okay, I think it's probably easier to just look at what it says in my, excuse me, in my editor here. Okay, so class alien. So it says use of undeclared identifier x coordinate. So it was supposed to be declared here, right? Int x coordinate. It says expected, oh, I've missed a closing brace somewhere. Which one is it? It's right here. That was crazy. Okay. It was right there at the end. All right, that's fine. So we'll try building that up. Okay, so run test. Okay, so now if we go into the test file, Okay, so it says, oh, teleport was supposed to, okay, so now let me look at the README again. Teleport was supposed to return a bool. Collision detection. For the time being, the function should return true. Okay, I kind of just spaced that. I read it, but I spaced it. So, hey, let's see here. All right, that's not too bad. So in this one, it says, did you mean health? Okay, so I have... Oh, I left out the get health. Okay. All right, let's submit that one. Okay, so not too shabby, not too shabby. So we were learning this concept of classes. I'll mark that as complete. Let me take a quick look and see if I see any refactors that I want. This is such a simple one. I think I would say I'm fine with this. I think I'm fine with this. I'm fine with this. Yep. Okay, let's take a quick... Wait. Do I want to refactor this one? Oh, I do want to Clang format, at the very least. Okay, so that's nicer. All right. Oh, you know what? Yeah, that's exactly what I wanted. So that's Clang formatted better. Okay, so let's resubmit it after it's formatted. All right, so now let's take a quick look at community solutions. So I'm gonna again sort by highest rep user, and I'm gonna start again with Siebenschläfer. Let's take a look. I wonder how you actually say that, because I'm pretty sure it's not like what I just said. All right, so we had a public alien. Oh, interesting. Yeah. So, huh. So we used a different syntax here, right? And this is one that I'm not familiar with. So let's take a look. C++ colon before constructor function body. Let's take a look. It looks like some kind of a shortcut. Let's see. Yeah, this looks... I think this looks similar. New... Okay, interesting. Do not delete questions with good answers. Jeff said so. Okay. So it's a member initializer list. You can use it for two things. One, calling base class constructors. Is that what we did here? It is, right? So we called a base class constructor. That's cool. Initializing data members before the body of the constructor executes. And did they do that here? Class demo public demo unsigned char le equals 5. So did this initialize len to le? It looks a little bit different from what this guy did, right? Because he used the curly braces. Okay. Okay, so here we tried to assign to a const, and the compiler said, no, stop it, right? Okay, so then in this example, we use the initializer list, and then that's fine. Okay. So here, instead of using an if, we used standard max from algorithm. That's interesting. I wonder if it is better to do it that way. C++ standard algorithm max. Let's take a look in CPP reference. You think this is recommended over using an if statement like I did? It seems like a small thing, but let's see if there's something to learn. So, does a comparison. Exactly. Let's see here. So we could say, let's see. So here we said if health greater 0, health minus minus. So we could instead say health equals health greater 0, health minus 1, or health, right? That's what we did here, right? No. It would have been that. Let's see what Sheben did again. Here, let's ask ChatGPT. Thanks for trying. For an American, can you explain how this word should most likely be pronounced? The German word Siebenschläfer can be tricky for an American to pronounce due to the unique sounds in German. Here's a breakdown of how to pronounce it. Okay, so we should say Sieben. Okay, so I was never close at all. All right, Sieben, and then should be Schläfer. Oh, okay, Schläfer was right, but this should have been Sieben. Siebenschläfer. Okay, cool. So, Siebenschläfer. All right, so that did max 0 or health minus 1, and then returned true. All right, so yeah, we could, yeah, so it would be like this. I like it this way, I think. It's not, from what's said here, it's not clear to me that this might be really better. I think it's just different, and I think it's fine. I think I like it my way. Okay, so health greater than 0, sure. This one seems fine. And then, yep. Okay. Okay, that seems fine to me. So I don't want to change. Oh, whoops. I don't want to change this. Do I want to change this? Yes. Let's try it using the initializers. So this is going to be like this. This is going to be colon x coordinate x. But they used round braces. So should we try it like that? Y coordinate y. I may have misunderstood something. Health 3. Oh, okay, yeah, that is okay apparently. Okay, let me look again. Yeah, that looks fine to me. I think that looks good. So let's see what happens when we Clang format it. Yeah, that seems fine to me. Okay, let's submit one last time and move on to the next one. Okay, I'll close all these. Did I want to look at any of these other things? Obvious things C should do. Set from Digital Mars. I don't want to look at this right now, but I love the way this site looks. This looks like it's straight out of 2003 or something, right? Kinda? I'm gonna give it a star. Okay. Alright, back to Exorcism. Okay, let's continue. So we did Ellen's Alien game. Let's do Election Day. Heck yes. Heck yes. Heck yes. Alright, we'll give it a shot here. Okay. Let's see what the README is about. All right, so here is our information. So this is going to be about references, copies, and references, I guess. So with our current knowledge, it is a bit cumbersome to update a variable with the help of a function. Every function argument is handled like a copy and does not change the original value. Depending on the size of your type, this can have serious consequences for the performance of your code. So we do adjust salary, int base, int kids, and we returned base plus kids times 500. What? What is the, is this a teacher's salary? Wait. Now a mother of twins. Adjust salary, now a mother of twins too? So do they increase a person's salary for like their own kids for them being a parent? Who came up with this? All right, so now a mother of twins equals adjust salary, now a mother of twins too. Okay, okay. References can be seen as aliases. Changes to them have an effect on the original variable. References use an ampersand in the type declaration. All right, so we'll do int balance 1000. All right, so then int and budget balance. So this is a int reference to the balance. Int pro computer wheels 699. Budget minus equals pro computer wheels. Is this a reference to something? What the? No, that's funny. What? It is. Ah! Apple Pro Wheels 699. Oh, it's like a total meme. Pro computer wheels. That's funny. I I thought it was a reference to like a comedy movie or something. It's a reference to a real thing. That's funny. Okay. And they're on Amazon. Okay, let's see what the reviewer said. It's got to be something funny. Apple is the best company. Apple is life. Apple makes the best products. Apple's products are very reasonably priced and useful. I love Apple. Apple loves me. I am not being held hostage by Apple. I love Apple. Apple loves me. All right, now we know. Okay, so reseeding, changing the binding of a reference is not possible. You cannot have an uninitialized reference. Okay, I'm not quite sure I know what this means yet. Before I look at the example, changing the binding of a reference. So could we say budget equals pro computer wheels or something like that? Wait a minute. So we did main account 1 million, side account minus 20, savings, main account and savings are 1 million. Try to reseat savings. So savings is a reference to the main account, and this is side account. And wait. Savings and main account are now minus 20, as this uses the value of side account. Right, okay. Compiler error, reference must be bound. Okay, sure. So with the power of references, you might not need to return a value from a function at all. Void is used as a return type in this scenario. Okay, so if we want to increase the power and we get a level, so then we can now increase the power on Goku. Yes, great. So that's cool. All right, so let's look at the assignment. This is actually, I don't think I ever used this feature in C++. So this is good. This is something new to me, I believe. A local school near you has a very active students association. The students association is managed by a president, and once every 2 years, elections are run to elect a new president. In this year's election, it was decided that a new digital system to count the votes was needed. The school needs your help building this new system. 1. Get the number of votes from an election result. The new system will need a way to get the number of votes from a counter. The election result struct is already created for you, and it's defined as struct election result with a string for the name and an int for the votes. Okay, cool. So as all members in the struct are public, you don't need to write a constructor to initialize an election result object. You can use an initializer list instead. Yay! So we can go ahead and we can say election result Hamilton, Alex 1804. Cool. So create a function vote count that will take a reference to an election result as an argument and will return the number of votes in the election result. Yeah, that's fine. So far, so good. Increment the votes of an election result. It's finally time to process the votes. Now you need a way to increment the votes in an election result. Create a void function, increment vote count, that will take a reference to an election result as an argument and a number of votes and will increment the election result by that number of votes. Okay, so for Aaron 1801, and we add 3 here, and there we go. Okay, vote counting and presidency. The school handed in their votes, and it is now time to check the results for the winner. Create a function, determine result that receives a reference to a final count and returns a reference to the election result of the new president. It should also change the name of the winner by prefixing it with president. The final count is given in the form of a reference to a vector of election results. A vector with election results of all the participating candidates. Okay, so if we make a vector of the votes for Summer Wheatley and Pedro Sanchez, all right, then we're going to say determine result, and then the winner will say President Pedro. To keep things simple, you can assume the following. The vector has at least one element. There will be no ties for first place. Okay, so let's go into our file. Do we have some kind of a stub? Let's take a look. Oh yeah, we do actually. We've got tons of stubs. Okay, cool. All right, so the election result struct is already created for you. Lovely, lovely. Okay, and then let's do this task 1. So we're going to create the function vote count. So I'm going to say int vote count, right? We'll take a reference. I think it's like this. Is it election result reference? Let's see if it yells at me. So far, so good. Let's look at task 2. My editor's not yelling at me, so I'm gonna move on. We'll see. We'll see how it goes. All right, so I love that they included so many stubs in this one. It means I like pretty much don't have to think at all. Okay, so increment vote count. We'll take an election result reference. Where'd the key go? Result. Oh, it's gonna take a number of votes. Int number of votes. Okay, so task 3. I guess I'll take the to-dos off there. So this one is going to be called determine result. All right, so we'll say int max votes equals 0. Did they say we could assume that they'll always be non-negative? And then for election result in results. Okay, and then here we should also say So we'll return the result at the end, but we're going to have to do some work. So we'll say if result votes greater than max votes, max votes equals result votes, result equals, oh wait, final result. Okay, so then here we'll say final result name equals president plus non-const L value non-const L value reference to type election result cannot bind to a temporary of type vector election results. Reference to stack. Yeah, that definitely sounds like I've done something wrong for sure, for sure. So I think this approach is not what I wanted. Okay, the election result struct is already created for you, sure. I think this looks okay. All right, let's see what it says now when I do this. It's gonna yell at me like crazy. It's gonna be like, you've done crazy things and you need to stop. You need to just stop. No, this is actually getting into more interesting material, I think. very gently, which I think I do appreciate. So we passed 15 assertion. Well, in that case, let's go ahead and submit. Okay, let's see what we got here. Let me look one more time. No, not here. Let me look one more time at this file. Let's just see if I want to try and refactor. So this is fine. Sure. Sure. Okay, so this is definitely the most interesting one, and I'm not comfortable with the way it is, so let's try and fix it. It just is something about it seems like a little much. But I guess the reason is that, like, if I were doing this in Python, for example, it would be way, way terser, I think. Do they have the same exercise in Python? Let's just see. Just as an example. So they don't have the same exercise in Python, which maybe makes sense because the point of this one is to do references, which is not really a thing in Python, right? Even so, let me just look at this. Okay, so right here. So if I were doing this in Python, so determine result, and we get a vector of results. So if I were to say def determine result, and takes results, and we were to say I think it would be terser. Let's see. Well, I'm not going to do it, but basically, well, basically I would just use a max and a comprehension here, and then I would return, yeah, I would return and then I would use a next and a comprehension. It would be a lot terser, but I don't want to do it because I don't have a test for it right now. I just want to move on, I guess, or something. I don't know. So yeah, I think the one thing is that, like, does this need to be like that? Like, that seems like it's too long. But that's, yeah, that's cryptic then if I do it like that. Okay, I'm just going to leave it. Okay, let's look at whether I can mark it complete. Sure. Community solutions. Here we go. So, again, highest rep. Let's look at Vang's solution. All right. So, here's the struct. Fine. Return result dot votes. Sure. Okay, let's see what we did here. So we did size t, winner ix. Okay, pretty much what I did. We don't have a max, though. Oh. Yup, that makes sense. That makes sense. Right, so they just kept the winner index and didn't bother with the max. So the max is legit extra. I'm not gonna change mine. To me, I think including this max does seem more clear, like more immediately clear when you're reading it, but it's not needed, and I wasn't even thinking about that. Because, yeah, whatever's at this final result index is going to have that max votes. I'm going to go to the next one. All right. Robot often refers to humanoid AI versus mechs being giant machines for combat. Okay. Yes, let's go back. Okay, so we did election day. Let's do whatever this next one is. Troll the Trolls? I don't know about that. That sounds crazy right now. All right, so let's see what this is about. Enumerations. So far, we have mostly handled numbers and strings. To model the real world, we might want a limited number of values that a variable can take on. You might want a dedicated type with a few distinct values with distinct names. For example, in a skateboard factory, having the deck material be a choice of only maple, bamboo, or plastic. You could use integers to encode those values, but you would have to use extra code to check if there is an invalid value coming from the system for the material. The meaning of those magic numbers, which we have here, is difficult to trace over the source code, and they are prone to mix-ups. Enumerations can be used to encourage expressive code and to restrict unintentional comparison mistakes. Let's look at an example usage. The specific term for this kind of enumeration is scoped enumeration. The snippet below shows how to write a deck material enumeration. Note the enum class keyword and the semicolon at the end of the definition. Okay, so enum class, deck material, and then we have these three options listed here. That's very fun. Now look at a pricing function in the skate shop and take note of the scope resolution operator, : specifying an enumerator from the enumeration. Okay, so here we have a deck price function. It takes a base price and a deck material. Okay, so a material will come in. And so now we're going to look at the deck material plastic. Okay, cool. Imagine you have a second enumeration for wheel material. Enum class wheel material. Steel, clay, plastic. Although the wheels and the deck can both be made of plastic, the two cannot be confused. They are different types: deck material plastic and wheel material plastic. Each enumeration will have its enumerators in its own scope, its own namespace. This is the reason they are called scoped enumerations. You might be thinking that with a name like scoped, there would also be unscoped enumerations, and you would be correct. Unscoped enumerations are becoming less popular because they all share the same global namespace. Because of the sharing, you could not have two unscoped enumerations with the same enumerators, like plastic in the example above. Also, unscoped enumerations implicitly convert to integers. Look at the example below for a surprising result. So we have an enum which has citrus fruits, lemons and oranges, and an enum which has ice cream of walnuts and apples. And so we say bool comparison, apples equals oranges. It says true, okay, because apparently we had apples ice cream and oranges ice cream. Okay, but if we try to say deck material plastic equals wheel material plastic, the compiler will say, stop it! If you want to convert scoped enumerations to integers, you can use static cast int. Okay, fun. Okay, so let's look at the switch statement. Like other languages, C++ also provides a switch statement. Switch statements are a shorter way to write long if-else-if statements. To make a switch, we start by using the keyword switch followed by an integer. We then declare each one of the conditions with the case keyword. We can also declare a default case that will run when none of the previous case conditions matched. Each case should end with a break or a return statement. So we have a price, adults, kids. All right, so now we have a switch, and we're going to say int group size, adults plus kids. Case 1, price equals 50, break. Okay. Case 2, price equals 70, and break. And then the default, price equals group size times 30. All right, fair enough, fair enough. Okay, so then on fall through. One important thing about the switch construct is that the code will, the code will continue to execute until it is stopped by a break or a return statement. This can lead to unexpected behavior. All right, so here we said price equals 70, and then we said, excuse me, price equals 50 here, and then 70 here, and then group size times 30. But look, after we did this, we totally clobbered it and then clobbered it again. That's craziness. We would have been okay if we had used break and break. Okay. The main use case for this continued execution feature is a statement that has several labels. Multiple switch results can map to the same piece of code to be executed. This way, in a booking app, for example, the called function for group sizes 2 and 3 can be the same. Okay, so we say switch group size, case 1, book room, break, case 2 and case 3, book apartment, group size, break, and then default book house, group size. Okay. Let's go to the assignment instructions. Your friend Helma made a small online game that rapidly gained popularity. It's called Hellmath. The small community attracted some trolls who make the game and the forums pretty unpleasant. Helma has asked you to work on a new permission system to separate troublemakers. The forum supports 3 different actions: read, write, and remove. There are 4 types of accounts, each with different default permissions. Guests can read posts. Users and trolls can read and write posts. And moderators can read, write, and remove posts. They have all the permissions. Wow, can you imagine if troll was a separate account type? That's so funny. So Helma has noticed that it is no use to ban troll accounts. Her strategy is to give them the illusion that their time is well invested, but their posts are only shown to other trolls. For anything that requires priority ordering, trolls are last in any sequence. When they enter a game, the pool of available players is also limited to other trolls. This practice is called shadow ban. All right, 1. Set up user types and permissions. First, define an account status enumeration to represent the 4 account types: troll, guest, user, and mod. Next, define an action enumeration to represent the 3 permission types: read, write, and remove. Okay. Promote trolls only to other trolls. Every post on the forums saves the account status of the poster in its metadata. Make sure that posts by trolls are only displayed to other trolls. Helma needs a display post function that gets 2 arguments of account status and returns a bool. The first argument is the status of the poster. The second one is the status of the viewer. Using namespace helmath. Display post account status troll, account status user. False. Display post account status mod, account status guest. True. Okay, cool. Check permissions for different users. Helma needs a way to check if a certain action is allowed for a user. Please implement a permission check function that takes an action as a first argument and an account status to check against. It should return a bool according to the permissions listed in the introduction. Permission check, action remove, account status guest. False. Permission check, action write, account status mod. True. All right. Grant game access and pair players. To keep the actual players in the game accountable for their actions, Helmath denies access to guest users. As mentioned above, Helma wants trolls to troll other trolls. Game connections between other users are unrestricted. Implement the valid player combination function that checks if 2 players can join the same game. The function has 2 parameters of type account status and returns a bool. Valid player combination, account status guest, account status mod. False. Let's see, so a guest and a mod. Oh, okay, so a guest cannot join. But a troll can join with a troll, but not anyone else. Okay, so build priority queuing with the, goodness. With the massive growth of the game and the forums, Helma now has to distribute computing power and bandwidth among users. To handle emergencies, moderators are given the highest priority. Guests are queued behind normal users, and trolls get sorted behind everyone else. Implement the has priority function that takes 2 account status arguments and returns true if and only if the first account has a strictly higher priority than the second. Okay, so if we have guest and mod, then we say false because they should be ordered the other way around. If we say user and troll, we say true because they are ordered correctly. Great. I'm not sure that that makes sense to me because so if it's true if and only if the first account has a strictly higher priority than the second. So here we say true and it's like, okay, that's fine. But if they were both guessed, then we would say false. But I'm not... I guess I'm not sure how that's going to be used. I would imagine that if they have the same priority, I would want to say true because they're ordered correctly. But I think I'm imagining something different than they're imagining. So let's go to our file. Oh, look at this. Look at this beautiful stub. This is so nice. Okay. Wow, this is so great. All right, easy peasy. Class enum, account status. Let me try and fix my posture a little bit. All right. I'm such a mess, man. So crazy. All right. Okay. Is that better? It's a little better. Action. Oh, man. All right. Was that what it was? Okay, so now we need to put the scope in here. Right? Now the line is super long. Okay, so use of undeclared. Let's see, it's supposed to be here. Namespace hellmath. Declaration does not declare anything. Okay, let's see. Class enum account status. I got those out of order, didn't I? Well, I guess I won't make that mistake again. Maybe I will. I don't know. Is that any better? Maybe a little. Okay, now what does this say? Okay, to do task 3. Okay, so the action, if it's read, write, or remove, task 4. And am I tired out? I haven't even been at it very long. Okay, so this one is a bool. All right, so here we're gonna say all right. Let's see what it'll say. Something wild, I'm sure. All right. Um, 80 assertions in 18 test cases? Oh my gosh, so many. Okay, well, I guess they passed, so that's good. Let's see if I want to refactor anything. I probably should. Like, these conditionals are kind of goofy, honestly. Like, pretty much all of them are. Um, so if they're both trolls, that's valid. And otherwise, it's valid if they're users or mods, but not guest. Um, so they were talking about using switches, right? And I think some of these would probably look more readable with switches. Let me go ahead and submit what I've got here. Okay, I'm gonna submit it. I think it should pass because it passed locally, right? I'm gonna mark as complete, but now let me just try refactoring using switches. Like this one's fine. I'll leave this one alone. But look at this one. Do you think this would be more readable if we used a switch? This one for sure I think would be. Let's look at how different this looks if we use a switch. So we're gonna switch on action. Okay. Case. Action read. Return true. Case. Action write. Return status not equal account status guest. Case action remove. Return status equals account status mod. Let's see. Control reaches end of non-void function. So I guess technically I've covered all of the actions here. But I suppose we need a default. Wow. Okay, so I do indeed think that this is much more readable than what I had before, probably. Switch action, and we have these 3 cases. And each case is simple. Okay, so I think that's a more readable way. Now let's try this one, display post. Yeah, again, that's a kind of a big, ugly conditional. I mean, it was quick enough to write, but I think it's sort of hard to read, you know? Maybe a little bit. I think a switch might be more readable. So we would say switch on poster, and then we'll say case account status troll, and here we return viewer account status troll, right? And then in the default, return poster. No. We return true, right? That's actually, that seems much more readable, I think. Let's see if it works, though. I think it should be fine. Yeah. That's nice. That's a big improvement, I think. Okay, so then let's look at this last one. So this one's, again, pretty ugly. Let's see how it looks if we turn it into a switch. So we're going to switch on player 1, I guess. Case account status troll, return player 2 equals account status troll, case account status user, case account status mod, return player 2 equals account status user, or player 2 equals account status mod. Default return false, right? I should probably just Clang format and where'd my music go? That was a Mickey Hart track, which I think actually used to play, so I guess something happened with that particular track. Some copyright claim or something, I don't know. All right, so I think this is fine. Yeah, I think using the switches is a big win for readability. So let's submit again. Okay. All right, community solutions. Let's look at the amazing Dennis. Okay, so Dennis has these. So they put an equals 0 here. Oh, wait a minute. Interesting. So they used enum, not enum class. I guess that's fine, right? So then we said if, okay. So I initially just returned like this crazy, let's see. So I initially returned just this sort of Boolean expression like this. Quick to write, but annoying to read would be my take on that. So here, this guy has said, okay, so if troll equals first, oh, I would consider this almost like a Yoda expression. Account status, troll equals first and first equals second. I gotta say, I like my way better. I like both my ways better. Okay, so here we did switch. Case read, write, remove. Okay, so that's pretty much like what I did the second time. Except, of course, they used the unscoped enum. And I don't love that I have to use this account status : troll necessarily. It's probably fine, though. All right, so then on task 4, so he put static cast. I had mine cast implicitly, and I think I'm fine with doing it this way, but maybe making the cast explicit is good too. I don't know. Okay, so then this one, guest. So if either one was a guest, we returned false. So that's kind of the opposite of the way I did it, right? Where I left that as sort of the default return false. Or actually, hold on. Valid player combination. So I kind of said that the default was to return false. Actually, yeah, I do think that this way of doing it is more logical for sure than what I did. In fact, I kind of want to go back and change mine because this is more logical. But why did they... That's interesting. So why are they using account status : but on action, they don't? Huh. You know, there probably is a reason for that, but I don't get it. Because we said accounts, enum account status, troll guest user mod. Huh. I can't even think what I would Google on that. I think it's okay. Account status troll. Okay, let's go to the next one. I don't know. I just want to go to the next one. Doctor data. Uh-oh, what is all this? Oh my goodness. In C++, declarations are often separated from definitions. Declarations are grouped into so-called header files, with the respective implementations placed in source files. You can think of the header files as an API. The header file will tell you what a codebase has to offer, without going into the details of how. The most common file extension for header files is .h. Some projects use HPP or skip the extension completely. I think there was something about this in Google's... I was looking at one point at Google C++ style guide. There's a pretty extensive document here. I didn't read the whole thing, but if I'm going to do much C++, I think it would be very worthwhile to read this whole thing. Maybe I'll do that later. So they were talking about CC files and H files. So those are the extensions they use. CC for source and H for header. Non-header files that are meant for inclusion should end in .inc. So yeah, so there was quite a bit about this stuff. This is a big file, right? And I think that it's valuable information that will help me if I'm starting to do much C++. Anyway, I'm not going to look at it right now, but I was just reminded of it. Okay. The definitions are located in a separate CPP file. Okay, so yeah, that's interesting because according to Google's own what do you call it, style guide, they use .cc for the file extension. .cc. In fact, let me see if there's something about that. .cc. So I guess I'm wondering if there is a reason. Okay, so here it is. File names. Let's just read this. File names should be all lowercase and can include underscores or dashes. Follow the convention that your project uses. If there is no consistent local pattern to follow, prefer underscore. Examples of acceptable file names: myUsefulClass.cc, 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 myUsefulClass.test.cc. Unit test and reg test are deprecated. Okay. So they're like, we can separate words using underscores in a file name, we can separate words using dashes in a file name, or we can mash all the words together. It's all fine. C++ files should have a CC file name extension, and header files should have an H extension. Files that rely on being textually included at specific points should end in INC. Do not use file names that already exist in /user/include, such as db.h. In general, make your file names very specific. For example, use http server logs.h rather than logs.h. A very common case is to have a pair of files called e.g. foobarh and foobarcc, defining a class called foobar. Okay, so that's common OOP practice right in C++. But here we were talking about using a CPP, so I don't know if there's a particular reason to use CC versus CPP. That's another, you know, I was gonna say that's a question that might be good for ChatGPT, but I feel like that's also a question where ChatGPT might completely make something up. So let's look at Stack Overflow instead. I think it's something that hardly matters, but let's see what somebody says. At the end of the day, it doesn't matter because C++ compilers can deal with the files in either format. I mean, it's not even a format, it's just a file name, right? Conclusion, it doesn't matter. Possible origin, CC, C with classes, CPP, C++. Oh, it matters to Clang++. When you give it a C++ header file with a name that ends in H, Clang++ warns you. Oh, really? CC is faster to type, says Thang. GNU GCC recognizes all of the following as C++ files. and will use C++ compilation regardless of whether you invoke it through GCC or G++. Big C, two C's, CPP, big CPP, C++, CP, CXX. Wow, okay. The big C case matters, so small c is a C file. GCC also supports other suffixes to indicate special handling. For example, "I" will be compiled as C++, but not pre-processed, intended for separately pre-processed code. Huh. You know what? That's a really great answer, I think. So that's exactly the kind of information I was looking for. Let's star that. Cool. So, if you want to write a library called QuickMath that offers a function superroot that you want to use often, the files would look like this. Okay, so here's a file named QuickMathH. So we say pragma once, all right? We say that we're using a namespace, QuickMath, and we have a declaration for a superroot function that takes a double x and an int n and returns a double. And then here's a source file, #include QuickMathH, #include CMath, and now we define the function QuickMath superroot, all right, double x, int n, and then we do while n, x equals standard square root x minus minus n, return x. Okay, cool. If you need to include a header that is only required by the implementation, the respective #include line is only needed in the source file. All right. Everything that is included in the header is also available in the CPP file, like the string library in the example below. Did I understand what I just read? Attention, the semicolon is needed after the declaration in the header file, but not after the definition in the source file. Many C++ exercises on Exercism start with two almost empty files, header and source. You have to check the star test CPP file to see the names and namespaces of the expected functions in order to solve the exercises. Fair enough. Fair enough. I am not sure I got what this is about. So if you need to include a header that is only required by the implementation, the respective #include line is only needed. Okay. They're talking about this. So we included the CMath here, but we didn't need it here. Okay. I don't know why I couldn't read that for a second. Complete brain fart. Okay, so classes and headers. Classes can become very complex, and their relation to the header/source partition might be confusing. One possible layout is to keep all the implementation details in the source file and all the declarations and member variables in the header. So let's take a look. So here's an example of robot flower H. #if not defined robot flower H, #define robot flower H, and we would end the if here, okay. #include string, all right. Namespace robots, class flower, private, bool needs water, int size, standard string. Okay, cool. And then we have public, and here's a constructor that takes these two parameters, but we do not include the function body here because this is just the declaration. Same here, same here, same here, and same here. And then in the CPP source file, we define the constructor first, all right? So we go ahead and do that, cool. Then we do the start next day. So we include the function body here. If not needs water plus size needs water equals true, okay. And then we define get name, return name, and get size, return size. Okay. Where's give water? Did I skip over give water? Okay, well, I guess give water should be here, but whatever. So when the header is used as an API overview, that is where a person would look for information like default values. The size parameter's default of the constructor is therefore handled in the header and not in the implementation. Okay, so put a default there. The definitions in the source file are prefixed with the namespace robots and the class type flower. So of course we do see that. All right, makes sense. So far, so good. Another layout option is a header-only library that does not have a CPP source file at all. Oh. Projects might use combinations of these layouts, and there is a lot of discussion as to what might be the best fit for each use case. So I think that Google file that I just had open, I think that does have some of that, what am I trying to say? I think it does have some of that discussion, pretty brief discussion about header files. Is it class format? Hmm. One space indent. Public, protected, and private. Okay. I don't think there's necessarily a ton of information. Is there any? Let's see. Wait. Okay, so we were talking about header-only library. In general, every CC file should have an associated H file. Okay, I'm not sure how much of it I get right now, but I think this is okay. Header only library, so everything was in here, so there's no separate CPP source file. Okay, so pragma once, it's an include guard. It ensures that the content of the file is included only once during the compilation to avoid errors. Oh, I think there was something about that here as well. So it says hash pragma is considered a non-standard extension, I guess. So are we going to say something about this? There is another more complex variation of an include guard that starts with if n def and ends with end if, and that is what we see, well, a little bit different. It serves the same purpose, and its usage is shown in the flower class example above. All right, so let's look at the assignment. You start your first day at an Australian company called Dr. Data, which specializes in information recovery. You aced your job interview through your knowledge of C++ and von Neumann probes. Okay. As you have seen a lot of test files, your new boss wants you to recreate the respective source and header files from some test code the company has recently recovered. In this exercise, you are going to recreate lost files. Currently, the content of the files is unusable garbage data. The workflow of this concept exercise is very similar to the structure of Exercism's practice exercises. The exercise introduction text is only one part of the specification. The test file is your definitive guide to solving a given problem. Due to the way C++ compilation works, the test results might not show up in the web interface until you have implemented a minimal version of every class, function, and enumeration that is required by the tests. If you receive compilation errors, they might disappear once you have addressed all tasks and tests. You have 4 tasks, all related to recovering the lost code in the header and source files. Okay, so you look at 2 recovered lines from the test files. Heaven Vessel Bob Robert Johansson. Heaven Vessel Will Riker 2 Star Map System Beta Hydra. Your sharp eye instantly recognized a namespace, Heaven. Okay. You also see that there must be a class called Vessel. Sure. The constructor can apparently be called with 2 or 3 arguments. Okay, so a name and a number, or a name and a number and a system. The first argument seems to be of type string. The second one is a number. It is possible to initialize the Vessel class with a third argument. The third argument comes from a star map namespace. It is an enumerator of type system. You even got one of the enumerations, Beta Hydra. Okay. Prepare the source and header files with your discovered information. You need 2 namespaces, Heaven and Star Map. The Heaven namespace has a class Vessel, which can be called with 2 or 3 arguments. The system enum is to be placed in the Star Map namespace and has an epsilon Eridani enumeration. Keep an eye out for other enumerations so that you can constantly update the system enum. I'm worried that this one might take me a while. I'm gonna have a break after I finish this one. Okay, so more details. Heaven Vessel Bob. Require Bob current system equals star map system sol. Require Bob generation equals 1. Heaven Vessel Bob 5 equals Bob replicate Mario. What? I don't know. I'm sorry. I don't know what we're saying here. All right, it's fine. It's fine. We'll figure it out. We'll figure something out. You find some more interesting lines. Okay. It almost seems like it's going on and on. File corrupted. Please supply valid C++ code. Okay. So the namespace was Heaven. And then the other namespace was Star Map, right? And then what went in the Heaven again? It was a Vessel, right? Class Vessel. And then this one had an enum class system. And it had Beta Hydra and it had Sol, and it had Epsilon Eridani. And it was at about that point that my brain felt like mush and I kind of stopped reading, right? So we had two vessel constructors, right? So a vessel, and let's hash include string. Let's using namespace standard. Okay, so then the vessel took a string name, int n, and then there was a second constructor, string name int n, and then star map system. What's the file name? Doctor data. Okay. So now we have to mess with the H file as well, right? So let's put the source file into there, because we need at least some of that, right? Probably pretty much all of it. Yeah, I guess we do need that as well. Yeah, let's just get rid of that. Okay, so undeclared identifier star map. Okay. So then this one should, I guess, include okay. All right, so what's our first complaint here? It says star map has not been declared, right? So it's supposed to be namespace star map. So we're not supposed to do this. We're supposed to say, and we're not supposed to define the class. We're supposed to say heaven vessel like that, right? And then we don't want to do that. Okay, so it's saying star map has not been declared, and this is in the H file. Okay, so let's go to the H file again. So does it need to be like that? Heaven vessel is private within this context. Okay, so then we need to make sure that we put this into the public region. Okay. Unused parameter name. Yeah, this is more like it. Okay, so now so that's gotten me started. So let me look at the README again and let's see if I actually understand more of it now that I've kind of gotten started. Okay, so we took a string and a number and a star map system. Two namespaces. Okay, so we have a current system and we have a generation. Okay, cool. So yeah, let's do these things. A current system, a generation, and a replicate function, right? Okay, so this class, it has a public current system, which is a star map system. And by default, this is star map system sol. Then we have a replicate, and we have a generation. So let's do int generation. And then we have a function that replicates, and this one returns a vessel, I believe. So we're going to say vessel replicate, and it takes a string name. So then okay, so now when I do this, I need to do did that format it? Yes, much better. Much better. Okay. So here I'm going to say is that going to work? Field generation will be initialized after field current system. Does that matter? Okay, so now let's do heaven vessel replicate name. And so this will be return let's say vessel, new vessel, name this generation, this current system, return new vessel. We do it like that. A type specifier is required. Okay, unused parameter name. Let's look in the README again. There's some more detail here. So we added a replicate, but we're still not using this name. I mean, it seems pretty obvious what I'm going to do with the name, but let's just look at some other stuff first. Okay, so here we have a name Homer and a system. Okay, so then we have something called busters, all right? And so we have a make buster, which increments the number of busters. So busters will be a public int field, and make buster will be a public function. Shoot buster will return a bool, and then it will decrement the public busters field. And then if busters is 0, then this will return false. And then let's look at a little bit. Let's see. Bob1, Marv, Milo, Howie. Oh, get older Bob. This one is, it feels like there's a little more going on in this one than in some of the previous ones, and that's cool. Get older Bob. So if we call heaven get older Bob, Bob1 Marv. Okay, so it's something to do with the generation number, right? So if we pass both of these in, then I think we're going to compare these generation numbers and return the name of the one with the older generation number, or the smaller generation. Then we have in the same system, and we have Alpha Centauri, Delta Eridani, Omicron 2 Eridani. Okay, so let's add some of those. Not spelling well, goodness. Okay, so then let's just say that it has a public string name, or maybe it's private. It doesn't seem like it's accessed, so it's likely private, I would say. No, that other function is going to get it, so I'll just make it public for now. String name. And then we're going to have a couple functions in here. So we're going to have a string and get older Bob, right? Which takes vessel Bob1, vessel Bob2, right? and then we have a bool in same system. Vessel Bob 1, vessel Bob 2. Okay. And then there was something about the busters, right? So there's an int busters. And then there was a void make buster. And then there was a bool shoot buster. Right? Okay, so now let's go to our source file. So let's see. So void heaven vessel shoot make buster. And then a bool heaven vessel shoot buster. And then that is going to be if this busters is 0, return false. Busters minus minus, return true. Okay, so then we had a bool for in the same system, right? Heaven in same system. Heaven vessel Bob 1, heaven vessel Bob 2, and then we return Bob 1 system, Bob 2 current system, I believe, and then we had a bool heaven get older Bob, heaven vessel Bob 1, heaven vessel 2, and then it is all right. So if the generation, so the higher the generation, the younger it is. So in this case, we return Bob 2 name. Okay. All right, unused parameter name. Let's go in here. So here we were supposed to set the name. So we do that. We want to switch the order, it looks like. Does it like that any better? It seems like it does. I've been spending a long time on this one. Oh, man. All right, so let's look in our test file. Okay, so we have in the same system. Okay, so they said in the same system, and I just messed up the name. Honestly, I like my name better. But whatever, it doesn't matter. So this should be in the same system. Yeah, I like my name better. Okay. So this one says create drone from I can't even read it. Create drone from replication. So when we do this, we should increment the generation, and I completely skipped that. So that should be in my source file. That would make sense, but I skipped it. All right. Well, apparently they all passed now, so let me just take another quick look at the README. So we did this. Get older Bob in the same system. Yeah, that's it. So let's submit. Okay, let's see if that's accepted. Okay, so it says passed. I'm gonna mark as complete, and let's real quick look at a community solution. So again, highest rep user. Let's look at Spromberger. Okay, so shoot Buster. If Buster's less than equals 0, return false. Decrement Buster, return true. Okay, fair enough, fair enough. Yep, that seems fine. So he just had V for vessel, so that's cool. Used a ternary here, I did the same, so it makes sense to me. And then in here, we had these. We had these fields here, non-method functions. I'm cool with all that. So I am going to take 5 minutes and come back to do some more, baby. All right. Sorry, I took a while there. Probably more than like 5 minutes, but all right. So I guess that was kind of a simple one overall. And we kind of did some OOP, but we're still not really getting into much of like memory management, really. Let's go to the next one. Do I have my music going? Okay, this is a good track. All right. Next. So we did Dr. Data. Next. Lasagna Master. Wow. Let's see what this is about. Could be an interesting one. Yeah, let's see what it's about. Whoa. Okay, so you have already used and written C++ functions in a couple of concepts. It is time to get technical. The code snippet below shows the most common terms for easy reference. All right, so we have a function declaration with a return type, a type signature, and don't forget the semicolon for the declaration. Okay. Definition. Return type, name, parameter list, function body. Misspelling. All right. Okay, so declarations can solve problems like cyclic references, and they can be used to separate the interface from the implementation. Sometimes you want to make sure that values cannot be changed after they have been initialized. C++ uses the const keyword as a qualifier for constants. All right. So we're not supposed to reassign because we already said it was going to be const. So he's like, stop it, stop it, stop it. Shouty case for constants. Recommended to reserve this casing for macros if there is no other convention. If you try to change a constant variable after it has been set, your code will not compile. This helps to avoid unintended changes, but also opens up optimization possibilities for the compiler. As a human, it is also easier to reason about the code if you know that certain parts will not be affected. You can also have const as a qualifier for function parameters. All right, so const int reference secret, constant reference guess. So when you pass a const reference to the function, you can be sure that it will be left unchanged. You will often see const references for objects that might be costly to copy, like longer strings. A third use case for the const qualifier are member functions that do not change the instance of a class. Let's see here, member functions. Okay, so string answer. Okay, so const is placed here. So the reply is always the same. Okay, so we use const string reference here for the question. This avoids a copy operation from the original object that was passed to the function. And then here we have const. Okay, function overload. Multiple functions can have the same name if the parameter list is different. That is called function overloading, and it is usually done if these functions perform very similar tasks. The function header without the return type is the function's type signature. A change in the type signature results in a new function. The play sound example has 6 different overloads to accommodate different scenarios. Okay, so in this case they're all void, but we can have one that takes a char note, a string solfege a, an int jianpu. I'm not familiar with this term actually, but I guess it's just something similar. Let's see. Where did it go? Numbered scale degrees always correspond to diatonic major scale. Okay, nice, nice. Does it say jianpu here though? Oh yeah, right here. Cheap viewers on streamboo.com remove the space. Thanks, fluttering pronunciation. Okay, let me go back. All right, so we could do a solfege duration. So different argument types, different number of arguments, different qualifiers. Okay, so we can have a vector string reference solfege, and we can have a const vector string reference solfege. That's interesting, actually. Okay. So these are 2 different ones. That actually surprises me a little bit. Let's see if we learn more about this soon. The return type is explicitly not part of the type signature, and you will get compilation errors if you have 2 functions that only differ in their return type. Of course, of course. The compiler will complain because it is not clear which of the 2 should be used. Some functions can get very lengthy, and many of its calls might use the same values for most of the parameters. The repetition in those calls can be avoided with default arguments. Okay, so if we have a void record new horse birth, I like this. I like this track so much. Have I discussed this one yet? Destination Milky Way. Let's take a quick look. Destination Milky Way right here. Let me just see it on the link. Let me just open the link. This is what it is. Space Radio, the Jazz Hop Cafe, Destination Milky Way, Grisp Topic. I love this track. I absolutely love this track. All right. So anyway, record new horse birth. Okay, so string name int weight, and then string color. So by default, the color will be listed as brownish. So fair enough. The dam by default will be listed as Al-Rukaba, and the sire by default will be Poseidon. Okay, sure. So we do have to include a name and a weight, but if we don't include anything else, we can say brownish, Al-Rukaba, and Poseidon. Weird how they changed that from brownish to brown, and Al-Rukaba had an M added, but whatever. All right, so then here we can choose off-white for the color and fall aspen for the dam, but we still are using the default sign. As the function declaration is often read before the definition, it is the better place to set the default arguments. If one parameter has a default declaration, all the parameters to its right need a default declaration as well. I love this track too. This is one of my favorites. Let's look at this one real quick too. This is a good track. Yuan Ellis Mirage. Actually, I don't know if that's how you say it, but that's a good track in my opinion. Okay. So, where are we at? Sometimes complicated function overloads can be refactored to fewer functions with default arguments to improve maintainability. All right, sounds like a winner to me, baby. So, in this exercise, you are going to write some more code related to preparing and cooking your brilliant lasagna from your favorite cookbook. You have 5 tasks. The first one is related to the cooking itself. The other 4 are about the perfect preparation. So, number 1, estimate the preparation time. For the next lasagna that you will prepare, you want to make sure that you excuse me, goodness. You want to make sure you have enough time reserved so you can enjoy the cooking. You already planned which layers your lasagna will have. Now you want to estimate how long the preparation will take based on that. Implement a function preparation time that accepts a vector of layers as a string and the average preparation time per layer in minutes as an int. The function should return the estimate for the total preparation time based on the number of layers as an int. If the average preparation time is not passed, then the default value of 2 should be used. Okay, so we said layers and 3, and we had, 6 layers, I guess? So we did 18, but we had a default of 2. All right. Compute the amount of noodles and sauce needed. Besides reserving the time, you also want to make sure you have enough sauce and noodles to cook the lasagna of your dreams. For each noodle layer in your lasagna, you will need 50 grams of noodles. For each sauce layer in your lasagna, you will need 0.2 liters of sauce. Define the function quantities that takes a vector of layers as parameter as string. Okay. The function will then determine the quantity of noodles and sauce needed to make your meal. The result should be returned as an amount struct, which is already defined for you. Amount has 2 member variables, one for the weight of the noodles as an int, and the second one as the volume of the sauce as a double. Okay. Well, seems pretty simple, right? So, let's see, we called amount needed, let's see. So we called the quantities function with, 2, 3, 4, 5, 6. Let's see, why did this come out as 100? Is it, so it was only adding if, so only if noodles, did we count it as noodles, and only if sauce, did we count it as sauce? Okay, I didn't get that at first, but sure. Add the secret ingredient. Okay, so a while ago you visited a friend and ate lasagna there. It was amazing and had something special to it. The friend sent you the list of ingredients and told you the last item on the list is the secret ingredient that made the meal so special. Now you want to add that secret ingredient to your recipe as well. Write a function add secret ingredient that accepts 2 vectors of strings as parameters. The first parameter is a reference to the ingredients of your own recipe, and the second vector of strings has the ingredients your friend sent you. The last element in your ingredient list is always a question mark. The function should replace it with the last item from your friend's list. Note, add secret ingredient does not return anything. You should modify the list of your ingredients directly. The list with your friend's ingredients can also be a reference for improving the performance, but it should not be modified. Make sure the list will not be modified with a const reference. All right, cool. Scale the recipe. The amounts listed in your cookbook only yield enough lasagna for 2 portions. Since you want to cook for more people next time, you want to calculate the amounts for different numbers of portions. Implement a function scale recipe that takes 2 parameters: a vector of double amounts needed for 2 portions, and the number of portions you want to cook. The function should return a new vector of the amounts needed for the desired number of portions. You want to keep the original recipe, though. This means the quantities argument should not be modified in this function. And 5, unlock the family secret. You remember stories from your childhood, tales of your great-grand-auntie, the guardian of the family's deepest culinary secrets. Legend has it that she holds the key to unlocking flavors beyond imagination, but her methods are unconventional. She doesn't deal in lists or measurements. She speaks in whispers, revealing only one ingredient at a time. With a mixture of excitement and trepidation, you decide to reach out to your great-grand-auntie. As expected, she responds in her cryptic manner, offering a single secret ingredient wrapped in mystery. Your great-grand-auntie's contribution adds a layer of complexity that you want to use in your recipe. Implement another version of the add secret ingredient function that accepts 2 arguments: a reference to a vector representing your list of ingredients, and a single string representing the enigmatic offering from your great-grand-auntie. So, if we pass in the secret ingredient like this, then this should be replaced like that. So, I don't know, seems simpler than what we were doing in the other one, but let's see if we've got a stub. So let's take a look at our H file first. Do we need to mess with the H file? It seems like yes, right? So let's put in the different functions. Were there 5 of them? There were 5 of them, right? So we have add secret ingredient overloaded, right? So add secret ingredient is void either way. How do you spell it? Ingredient. Okay. And it takes a string vector. Vector, string, my layers, right? And that's a reference. My layers. And then we have const vector string friends layers, right? Okay, so now let's go ahead and hash include vector, hash include string, using namespace standard, and then here we are going to have another version, which is just a string, right? And this is auntie. Okay. So then, let's see, what were the other ones we had? Quantities. One of them was called quantities. It was supposed to return an amount, and it was supposed to take a vector. So this one would be a const vector string layers. Okay, so that's 3 of them, I guess. All right. Then what were the other ones? There was one for the preparation time, right? So int preparation time. Wow. What am I typing? Preparation time, which takes a const vector string layers, and it takes an optional int average time with a default value of 2, right? Okay. Nice, nice. What was the other one? I feel like my brain is mush. It's probably always mush. Okay, so... Oh yes, scale recipe. I think I read this one, but I completely did not understand it or process it. Okay, vector of double amounts needed for 2 portions, the number of portions you want to cook. Okay. Quantities and portions. So this is a void, and this is scale recipe, const vector double quantities portions. All right, let's go. I don't think this is quite right. Let's see here. So these are supposed to be cased like this. So let's go ahead and fix that. Was preparation time the same? I would assume it would have to be, right? Okay. Okay, so let's not do this. All right, let's not do that. And we don't need this. Okay. So we'll get rid of the default argument, as the editor is helpfully telling me. And then here we are going to return average time times layers size. So far, so good? Okay. Okay, so then here we're going to go through each layer. So let's say amount result, and then it's supposed to be 0, 0.0, 0.0, I think, to start with. No. Okay. So, excuse me. We'll return result at the end. So we'll go for string layer of layers. If layer is noodles, result noodles plus equals 0. What is it? Plus 50, right? Yeah. And then if layer equals, let's say else if maybe, else if layer equals sauce, result sauce plus equals 0.2. Yeah? Return. What am I doing? Okay, there we go. All right, let's do scale recipe. Okay, so here, why is it quantites? hold on, let me change that in the H. Quantites. Quantities. Okay. So here we're going to go for oh wait, how come I have it as const here? Let me look at the README again. So for this one, we're supposed to change it? Or what are we supposed to do? It should return a new vector of the amounts. So we do not modify the quantities. Okay, well, I messed that up. So it should be vector double. Okay, so then this one is vector double. Okay, so then we'll say vector double scaled reserve size for double quantity of quantities okay. All right, let's do add secret ingredient. Okay, so what are we going to do here? So it's not last, it's let's just look at that real quick. C PP reference vector. So there's something for like the last, right? Oh, back. Access the last element. Can we do that? Okay, last one. Oh, let's get rid of that. Okay, so now these are going to become lasagna master I guess that seems okay so far. Oh, a bit slow to build, I guess, but okay. So we passed the 34. All right, let's go ahead and submit then. opened up over there. All right, here we go. Lasagna master. Okay, processing. Passed. All right. Let's mark as complete. Okay, how many have I finished so far today? I feel like I'm going so slow, really. I've only done... Where did I start today? So I've only done 5. I guess that's not so bad. It's kind of bad, actually. It really is kind of bad. All right, let's take a quick look at community solutions. Highest rep. Let's look at Nacho Goro. Okay, so they included algorithm. Let's see what ends up happening here. So size times average time. Is this what I did? I feel like my file looks like an absolute mess. Oh no, not this one. Average time times layers size. Fine. Oh, interesting. Oh, so they didn't use the default. We were kind of told to use the default parameter, right? This is fine. This is a fine other way to do it. Okay, so then quantities, we said we had a result. Yeah, that's fine, I think. Then we said auto. So using const there does, I think, make sense to me. And yeah, this is fine, I think. Then for scale recipe, let me see what they did. Okay, so we defined a result. Okay, yeah, that makes sense. So I did this reserve thing, but I don't know. This makes more sense, probably. Here we did a transform. So transform comes from algorithm, I guess. Oh, interesting. So is transform like a JavaScript map? Let's take a look. C++ standard algorithm transform. Applies the given function to the elements of the given input ranges and stores the result in an output range, starting from D first. Cool. Okay, that's actually really good to know. Let me go ahead and change mine to do that then. So we're going to try using transform. So we're going to go to the top and say include algorithm. All right. And then we're going to do transform. Okay, cool. So we're going to put in an input iterator first, input iterator last, output iterator result, unary operation, unary op. Okay. So we're going to take quantities. Do we have any hints for like, oh, I don't, it'd be good to have IntelliSense for hints on like method names and stuff. Okay, let's look at vector here. So iterator invalidation, member types, iterator, begin, an iterator to the beginning. Okay, cool. So begin, quantities, end, scaled, And this one is supposed to be what? Output iterator result, so scaled begin. And then a unary operation, unary op. So is that's a C++ style lambda, I think. Let's take a quick look at the example shown. So we did, oh, this is a possible implementation. Let's look at the usage example. Begin, end, begin. Okay, so we passed a plus in here. We passed a 2 uppercase here. I think we want to try to pass a lambda here. So let me think. So I have to review. We do something like, let me, oh shoot. Let me just put it into Google again, and I think it'll tell me. C++ lambda among this function. I think the Google AI will just tell me right away. Capture list, parameters. Okay. So we're going to capture a double quantity. No, that's not right. Okay, we don't need to capture anything. What are we doing? We just need a parameter. So double quantity. The capture is for a closure, right? Something like that. That's cool. That's cool. I don't think we need it for this. And then we just put a return type. And then, oh, we do need a capture actually. Right? Okay, so quantity over 2 times portions. Yeah? Okay, so transform. Okay, so let's see if that works. No. All right, but this is something I need to know how to do for sure, I think. Okay, so we failed. So we tried to scale and I just got zeros, so it didn't work. Okay, so quantities. Quantities begin, quantities end, scaled begin, capture portions, take quantity, return double, return quantity over 2 times portions, and then return scaled. Okay, so it didn't quite work. So here, so this was a vector unsigned ordinals. They used cbegin. And what is cbegin? Begin and cbegin. Oh, I didn't look at what is the difference. Begin and cbegin. Iterator begin, const iterator cbegin. C begin, C end. Hello begin, to uppercase. Okay. So let's change these because we're not trying to mutate quantities at all. So that should be C in both cases. I don't think that's going to fix it though. So then I have scaled begin. To uppercase in place. Here we have ordinals. Standard copy. Okay, so what have I missed here? I tried passing a lambda as the... Well, I mean, I tried doing this. Here's the thing, though. I did do something like this, or I used a syntax like this in one of my previous exercises. So let me go back and see if I can see what one that was. Because there's a bunch here, right? Was it in all your base? No, I don't think it was this one. I did do, there is some there that's a little bit similar. Let's see, what was last will? No, not last will. What about reverse string? Was it maybe reverse string? Let's see. What did we do for reverse string? Okay, well that makes sense. What did we do for secret handshake? Was it all your base? Because we have a function bool int predicate, right? So where do we actually use that? Right here, right? So we said from. Okay, so we used a predicate here. Function bool int predicate. From was captured. Okay, I mean, that seems cool. Okay, so in our lasagna master file, we're trying to use this transform, and I do want to make this work. So we're supposed to take a unary operator, unary operation. Unary op, unary operation function object that will be applied. The signature of the function should be equivalent to the following. Const. The signature does not need to have const reference. but it could, right? Okay, but I'm still getting the zeros, right? Oh, wait a minute. Oh, my scaled doesn't have anything in there. Expected size. Oh, okay. I wasn't even looking. Oh, interesting. So I reserved, but we don't want to do that. We want to say... We don't want to reserve. We want to do something else. We want to resize. So reserve is here. But we don't just want to reserve storage. We want to actually make it larger. Resize. Okay, so is that it then? Yeah, that's it. Okay, cool. So now let me look. So this is what we did. So we said scaled. We resized it to the size. Then we did a transform. And we did portions. Okay. So the anonymous function syntax here is maybe a little on the verbose side, but I do think it's cool. I think it's cool, cool, cool. So let's resubmit that now that that's working. And then let's look at what else was in the other person's solution. Okay, so the scaling. So they did transform. Okay, cool. So they did pretty much the same thing. They put people, they put a quantity. Yeah, totally. Oh, interesting. So they used begin and end functions here. And are those from, where are those from? Are those in vector? Standard vector begin, C begin. Okay, interesting, interesting. I like that. Begin, end, result begin. Okay, so then on add secret ingredient. Oh, okay. So here, this is good. They used this one as part of the implementation of this one. Let me see. Do I want to make that change in mine? No, I'm fine with mine still being this way, but this is also smart. So here they did pop back and push back. Do you think that's better to pop that and then push the other one instead of doing a reassignment like this? Comments are disabled on this one. Hey, you know what? Let me go to mine and enable comments, and I'm just going to go on to the next one because I do want to finish at least. I can't believe how few I've finished today. Let me go ahead and enable comments. At least, hold on. Where do you go to enable comments? So let's go to newest. So is there an option? Let me just look real quick. Settings. Do we have an option to enable comments by default? These are emails, donations, insiders, preferences. Okay, use this setting to control whether or not people can post comments on future solutions that you publish. This can be overridden on a per solution basis, and you can update all existing solutions below. Okay, so let's make this the default. And let's allow comments on all existing solutions. There we go, baby. Okay, cool. Let's go to the next one. Let's close all these tabs. Okay, next one. Speedy Wagon Foundation. Okay, so this is actually the last of the learning exercises, right? So hopefully we learn some of the actual memory management stuff. I'm assuming some of it has got to be covered a little bit. Interesting. Like many other languages, C++ has pointers. You already know references and pointers are similar, but think of them as a level closer to the inner workings of your computer. Pointers are variables that hold object addresses. They are used to directly interact with objects, enabling dynamic memory allocation and efficient data manipulation in C++. If you are new to pointers, they can feel a little mysterious. You know, I don't think I've observed that, but that is the second time I've seen that. In the boot.dev memory management course, they said something very similar. So that's interesting. My perception is not that people find pointers mysterious, but just that they're kind of foot gunny. People make mistakes with pointers. I myself make mistakes with pointers quite a bit. And that's why we complain about pointers. Not that they're mysterious. I don't think they usually seem mysterious, but anyway, once you get used to them, they're quite straightforward. They're a crucial part of C++, so take some time to really understand them. The bare-bone version in this concept is called dumb pointer or raw pointer. With modern C++, there are also smart pointers. The basic type is not smart at all, and you have to handle all the work manually. Before digging into the details, it's worth understanding the use of pointers. Pointers are a way to share an object's address with other parts of our program, which is useful for two major reasons. One, like references, pointers avoid copies and help to reduce the resource footprint of your program. Two, unlike references, pointers can be reassigned to different objects. Three, pointers can also point to a null value to indicate that they currently do not point to any object. All right, fair enough, fair enough. A pointer declaration in C++ involves specifying the data type to which the pointer is pointing, followed by an asterisk star and the pointer's name. When pointers are declared, they are not automatically initialized. Without explicit assignment, a pointer typically holds an indeterminate value, often referred to as a garbage address. Cool. Cool. I'm all about the garbage, baby. Oh yes, oh yes. I thought I might have had another can. Hold on. Let's see. Do I have B-top? There's my B-top, baby. That's the default B-top. Okay, that's cool. Let me just take a sec. I'm gonna look around a little bit. Should be less than a minute. Because I think I might have left something somewhere. Or maybe I'm crazy. I sure think I seem crazy. Okay. Oh wait, I found it. Okay, gotcha. VTOM. I think VTOM, this is like one of the best terminal screensavers, I think. It's just pretty neat. Here, let's see. Do I have NeoFetch as well? That's another good terminal screensaver type gizmo. I've been messing with terminal screensavers on the Mac. Well, all right, let's see how this comes out. Ubuntu, nice, nice. Alacrity terminal. These are my color schemes. I might want to update these color schemes. It's in my Alacrity toml file, right? Where is that? I forget. Oh, it should be here. Alacrity. No. Which one do I think it is? I forget. Is it config? Yeah, I think it's that. Okay, let me go back to where I was. No, it's supposed to be like this Alacrity toml file. Okay, hold on. That's where I thought I was looking. Oh, wait. I left out the dot. There it is. There it is. Okay, so I'm using a Hatsune Miku theme. That sounds like a winner to me, baby. But let's see what else is in themes. Okay, so here are the themes. So I have got Hatsune Miku. Okay, should we try one of these others, like Hard Hacker or something? Just going by the name. Sure, let's give this a shot for a little bit. All right, so let's go back to the README. Oh, wait, no. Oh, that's horrible. The, oh, that's way too little contrast on that. Okay, let's change it then. How about going just by the name? Which other name sounds interesting? Rainbow? Let's see rainbow. Oh, this is nice. Ooh. Okay, so I lied. It's not nice. Let's look again. I liked Hatsune Miku quite a bit, but I want to try something else. Let's see. Cyberpunk Neon. Let's give that a shot. Oh, okay. Ah, I do like that. Yeah, I do like that. Okay, let's give this a shot. It's a little harsh compared to Hatsune Miku, but sure, let's give it a shot. All right, enough wasting time. Okay. Where was I? I had hardly gotten through any of this. So, garbage address. While certain compilers might initialize pointers to null pointer, this behavior is not guaranteed across all compilers, so it's essential not to rely on it. It's best practice to explicitly initialize raw pointers and verify their non-null status before utilization to avoid potential issues. All right, so here we initialized it to null pointer, declares a pointer and makes sure it is not invalid. Okay. To assign the address of a variable to a pointer, you use the address of operator. Yay. Dereferencing a pointer is done using the indirection operator, star operator. Okay, so if we have a string that says Solomon Lane, then we can make a pointer, a string pointer, that points to address of Solomon Lane. And then, instead of Ethan's, the opponent's name address is given to the passport. What the? Dereferencing has to be done explicitly, while references just worked like an alias. Okay, good. Pointer arithmetic. Pointer arithmetic allows you to perform arithmetic operations on pointers, which is particularly useful when working with arrays. Adding an integer to a pointer makes it point to a different element. Okay, so we have a Stargate coordinate code, gate code, sure. So then we can have a pointer pointing to the first element like this. Gate code 0 here, sure. Then we can add 2 here, and we found the right place, apparently. So pointer arithmetic in C++ can easily lead to undefined behavior if not handled carefully. Undefined behavior can manifest in unexpected program outcomes, crashes, or even security vulnerabilities. One infamous example of the consequences of undefined behavior occurred in the explosion of the Ariane 5 rocket in 1996, where a software exception caused by the conversion of a 64-bit floating point number to a 16-bit signed integer led to a catastrophic failure. In C++, the arrow operator is used to access members of an object through a pointer to that object. It's a shorthand which simplifies accessing members of objects pointed to by pointers. For instance, if pointer is a pointer to an object with a member variable x, instead of using dereferenced pointer.x, and that's what it's called, the star operator is indirection. So this is indirected pointer.x. Why is it called indirection operator? That sounds so weird. Dereferenced pointer.x, you can directly use pointer arrow x. This operator enhances code readability and reduces verbosity when working with pointers to objects. Here's a brief example with a struct superhero that has a member variable superpower. The main function creates a pointer Diana prints to a superhero object representing Wonder Woman. The arrow operator is used to access the member variable superpower showcasing Wonder Woman's iconic lasso of truth. Okay, so we have a struct, and there's a superpower string, and then we can have a superhero, sure, and then we can have a pointer to a superhero, right? So we get the address of operator, and so now we can do an assignment. We can assign this string through here, all right? So now if we look at Wonder Woman, oh, interesting. So we did delete Diana prints here, and I guess that deletes this. They didn't really talk about it yet, but let's see. Pointers and references both, because I'm used to seeing delete used with, or like paired with new, right? So we didn't say new, but I don't think we needed to. I think we're just going to delete it. I'm just not quite accustomed to seeing it that way. Pointers and references both enable indirect access to objects, but they differ in their capabilities and safety considerations. Pointers offer the flexibility of changing their target object and can be assigned null. However, this flexibility introduces risks, such as dereferencing null pointers or creating dangling pointers. References, on the other hand, cannot be null and are bound to valid objects upon creation, avoiding these risks. Given their safer nature, references should be preferred over pointers unless the additional functionalities provided by pointers are necessary. Okay, let's look. Here's the assignment. Welcome, engineer. You are one of the last veterans of the Speedy Wagon Foundation, a secret organization that for decades has been battling ancient threats like the Pillar Men. In the course of this effort, you've spent years maintaining the Foundation's technological systems, built using a mix of cutting-edge tech and aging libraries. However, in recent times, the sensors that track Pillar Men activities are malfunctioning. The Foundation systems are old, and the code interacts with a legacy C++ library that cannot be updated. Your task is to implement 4 core functions that monitor Pillar Men sensor activity using an old-fashioned pointer-based library. As a modern C++ engineer, you'd prefer using smart pointers, but alas, legacy code demands respect for the old ways. The fate of humanity may rest on these pointers, so proceed carefully and may the Hammond energy guide you. As sensor readings can be huge, we supply a mock-up struct that is used in the actual library. The code has already been implemented in the header file for you. Okay, so we'll see some kind of struct like this. That's cool, that's cool. So 1, check sensor connection check. Your first task is to ensure that the Pillar Men sensor is connected properly. We can't have false alarms triggered by disconnected sensors. You will write a function connection check which tests if the sensor's pointer is valid by checking for null pointer. Alright, so define a function that accepts a pointer as a Pillar Men sensor struct. Okay. The function should return true if the sensor pointer is not null, and false otherwise. Alright. So if we put this null pointer in here, then it should come back false. Alright. Cool, cool. So that's our connection check. Then count activity of sensors. Activity count. Pillar Men are lurking in the shadows, and we need to know if sensors have detected any activity. You will write the activity counter function, which takes in an array of sensors and a capacity indicating the number of sensors in the array. Define a function that accepts a pointer to the first element of an array and the array's capacity. Use pointer arithmetic to loop through the sensor array and accumulate the activity readings. Return the accumulated activity. All right, so if we have this array come in and then we do activity counter, then we're supposed to do the sum. Okay, easy peasy, right? Okay. All right, alarm control. Not every sensor should trigger an alarm unless there's real danger. The alarm control function ensures, The alarm control function ensures that a sensor only triggers an alarm if its activity level is greater than 0. This function should also check for null sensors to prevent system crashes. Define a function that accepts the pointer to a Pillarman sensor. The function should first check for a null pointer sensor. If the sensor is null pointer, return false. If the sensor is valid and its activity is greater than 0, return true. Otherwise, return false. All right, so Pillarman sensor, DB, so there's a 9008 and some name, I guess, Sango Kunoi, and some 7s, I guess. All right, so then we'll say, should there be an alarm? And we'll say true. So the activity number is this 9008. All right, checking the data for anomalies with the UV alarm function. In this task, you will implement the UV alarm function to determine whether an alarm should be triggered based on UV light exposure levels and sensor activity. The UV alarm function should use the provided UV light heuristic function, which operates on a vector of data and returns a value based on certain thresholds. This is a mock-up version of the complex code that will run during production. Please don't change the interface. Okay, so define the UV alarm function in the Speedy Wagon namespace. It should take a pointer to the Pillarman sensor struct as its parameter. Return false if the sensor pointer is null. Call the UV light heuristic function, passing the address of the sensor's data array. Return true if the value returned by UV light heuristic is greater than the sensor activity level, otherwise return false. Okay, I'm afraid this one's going to take me a while. I'm pretty sure this is going to be the last one for today. There's a lot being said here, man. Oh my gosh, you know what? It's not showing... What the heck? Something about this is completely messed up. Okay, I'm just going back to the other color theme. This one was fine. Yeah, man. Alright, yeah, this one's fine. So, let's go into our file, Speedy Wagon H. Okay, so we have this defined, cool, and we have this. I think this might already be enough. Let's see. Let's go into the CPP file. Please don't change the interface of the UV light heuristic function. Okay. All right, that might be fine. Okay, let's look at the README one more time. All right, so we're supposed to do connection check. So this is bool connection check, which takes a Pillarman sensor, PMS, I guess, and then return PMS not equal null pointer. Okay, my bad, my bad. That's me not paying attention. So we'll put the implementation in. Okay, what's next? Connection check. Activity counter. So it takes an array and returns a sum. Oh, it's actually a C-style array, right? Let's look again. Capacity indicating the number of sensors in the array. And then I messed this up because what? Does it go here? Okay. That's me just not being very familiar with the syntax, obviously. Okay, so then we have an alarm control, which takes a pointer to a Pillarman sensor. Oh, and what does it return? A bool. Okay, and then the last one is UV alarm. Okay, so now let's go into the source file. Okay, so we have bool. Here, let's just open the Okay, I'm gonna have them both open like this just to help me out. I don't usually, but let's just do it this way. Okay, so yeah, this makes it easier. Connection check. Then we're gonna do int activity counter. So I'm just gonna say int sum, and then for. So they were telling us in the README to use pointer arithmetic or whatever. So I guess that's fine. So I'm gonna say I think that's allowed on a C-style array, probably. So I'm gonna say for and then we want to add the, what are we adding here? The activity? Whoops. Yeah, it is just the activity, right? Okay, so here we're going to say activity. Okay, so then for this one, we want to say alarm control. Are we able to see that okay? I think so. Okay, let's see here. So for the alarm control, it says we are supposed to, if the sensor is null pointer, return false. So we'll say if PMS null pointer, return false. Okay. If the sensor is valid and its activity is greater than 0, return true. Okay. So let's just say return PMS not equal null pointer and PMS activity greater than 0. Yeah, let's do like that. Okay, so then this next one, we are going to say UV alarm. And then what? Return false if the center pointer is null. So we're going to return PMS not equal null pointer and UV light heuristic address of PMS data. And we want to say that is greater than PMS activity. Yeah. Okay, so then it looks like they're using the word sensor. So let me actually change this. This will be sensor, and here as well. Sensor, sensor, sensors, plural, sensor. Let's just replace it everywhere. Except for here where it should be plural. Okay, so it's going to be Speedy Wagon. Yeah, this is going to be the last one, but if it might be just about done, and if so, then that's actually faster than I thought it was going to be. Let's look into the tests. Okay, let's submit. Not too shabby, not too shabby. All right, let's bring this over here. Okay, let's take a quick look at somebody's solution. Some of these are just, the readmes are so long compared to like what the actual solution is. Okay, let's see what Ryan++ has for us. Okay. All right, so that's fine. So here, so null pointer is 0, right? And so that's what's happening here. I like that. I'll maybe keep that in mind for next time. I don't think I'm going to change mine right this second. They used auto here, that's good. Okay, so they didn't actually do the pointer thing that was suggested in the README. I think this way is a lot better, but it's not quite what was suggested in the README, I don't think. Yeah, that's fine. Okay, so let me see. I'm gonna take like 5 minutes. Ubuntu use AUR. Not an equivalent. I want to use the actual thing. Or I want to see if we can use. Oh. All right. No, I was just wondering, like, well, I'll tell you exactly what's wrong with it. It's that I wanted to install a nerd font, and it specifically said they're available on AUR. That's the reason I'm thinking about this. Arch Community Repository. So let's look for Ubuntu package repo nerd fonts. Chocolatey? Wait a minute, can you use Chocolatey on Ubuntu? No, you cannot directly use Choco. Yeah, why would I even think that? It's because it was right here. I'm like, what is happening? Okay, so let's look at what this devto said. Oh no! Yeah, but I mean, this is fine. I'm just looking for whether there's a package management system that will enable me to get it. So it's just saying to download it, which is fine. Is it weird that I want to find another alternative? I don't know, because on the Mac, I always just do this, but it's a cask, so I can't use it this way. So it's right here, Comic Sans. Patched font Comic Sans from Nerd Fonts library, right here. Oh, wait a minute. Why don't I just do it from here? Maybe that would make more sense. Well, I'll think about it later. For now, sure, let's just download the file. It's fine. Oh, that's not right. I'm exposing myself for being dumb and not knowing anything. It happens all the time. Okay, so we've got the Comic Sans Mono Zip. Okay, so now we have these OTF files. Okay, so here they are. So we want these in fonts. When we use move and we use globs, okay, let's try it. Not. I wish I were more savvy. But you know what? Maybe I'm learning. Let's just put it that way. Okay, so all the OTF files, we want to move to fonts. I don't have fonts. Wait, what did they say it was called? To fonts. Okay, maybe I have to make the dir. Okay, so now there's the fonts files, and then what did they say to try next? FC cache. Generate font cache files. Force a rebuild of all font cache files. Okay. So they said that they forced it with V. V is verbose. So what if we just do FC cache? Okay, so now what if we do our alacrity file? Oh, no, it's this one. Okay. I have font size. Font. I think it's family or name. Let's see. Alacrity, toml config. So if I just go font family equals Comic Sans Mono Nerd Font, unused config key family. Okay, so it's not family. What is it? Is it so do we have to do normal? Okay, so these fall back to the normal. So we do font normal, and then we do this. Okay. Oh, okay, so there's our comic look. I had gotten really used to the way it was before, but I'll give this a shot for a while. Okay, so exorcism. What's the one we were just doing? Speedy Wagon? I think I like this style. So was there something I was thinking of changing? So technically, we don't need this part, because if it's null pointer, that's 0, right? Should we resubmit? Sure, let's resubmit. All right, that's it. I'm gonna log off. Really slow day, but whatever. That one's processing. All right, so basically I finished, what, 6 today? That is so few. That is crazy. I did 1, 2, 3, 4, 5, 6. And I did these 8 the other day. 1, 2, 3, 4, 6, 7, 8. I thought 8 was slow, but 6 is really slow. But they were just really long readmes, and I was trying to read the whole thing, and that probably wasn't really necessary. I don't know if it was even helpful. Oh, a new badge. Conceptual. Completed all